Worked. Great, thank you. Good afternoon, everyone. Welcome to the Thursday, January 29th, 2026 HamSCIence Zoom call. Normally this time of the month, we just basically have an open net, entertain all sorts of different discussions and questions and answers. But today, I think we're very fortunate to have a presentation on medium wave DXing. Actually, a DXpedition where a few fellows over in Japan took their SDRs and antennas and set up at a remote location, which you'll see in a moment. So a little bit our presenters. Coming from Japan, I'd like to welcome Satoshi Miyauchi, JP1SCQ. He's coming to us from the Yokohama area in Japan, where of course it is quite early, 14 hours ahead, about 6 o'clock in the morning there right now. Satoshi has been in the radio hobby for just over 50 years, like many of us starting quite young, in his case 10 years old. Started by listening to shortwave and medium wave stations and became a radio amateur in high school, which is almost my same exact story. Some of his recent activities include medium wave DXpeditions, which we'll see about today, using software-defined radios. As far as his amateur radio operations, enjoys the digital modes, including the FT8, for HF DX contest, as many of us do. And also the presentation was put together by Nick Hall-Patch, VE7 DXR. Most of us know Nick, but as a refresher, he's been a ham since 1989, but he was interested in medium wave DXing for many years before that, particularly interested in the propagation of medium wave signals from other continents. This interest has continued to the present day, though Nick in the past has readily admitted that drawing conclusions about propagation have not come about quite as easily as just making the observations. Prior to his retirement, Nick assisted oceanographic researchers by designing, building, modifying, and maintaining electronic instrumentation. So with that, again, thank you both for presenting. Good afternoon to everyone, or good morning and good evening, as the case may be. And Nick and Satoshi, I'll let you guys do a screen share and take it from here.
All right. Thank you. Thank you very much for your introduction. And it's an honor to be here. Sorry, my camera is not showing so properly, but it's just like the background sun. This is not the real one, but this is the virtual taken from the venue that we had. We have a very nice listening point in Tohoku area. Okay, yeah. So I'm going to show you the slides that we have prepared. Actually, that we are very much surprised to see this kind of data. So that was the starting point. Then I started to share with Nick about what has been happening. Then we have been questioning. Then it came to here. Okay, all right. I'm trying to share my screen as a presentation mode, but are you watching my?
Yes, it looks very good.
Okay.
Yes, there's screen number 2. Yes.
Okay. Yeah. So this is the number screen 2, the DXpedition brief itinerary. That is only the weekend sessions. But some of us will go to Tohoku area. Tohoku area is about 500 kilometers, or just roughly 300 miles north of Tokyo. And we can be there about 2 hours and 10 minutes or 2 hours 30 minutes by bullet train that you can see here. Then there will be another 2 hours drive to the coast area. Because Shinkansen is running almost in the center of the island. So it be the Saturday and Sunday nights that we listen to. Then we could go back on Monday. One of the reasons is that on Sunday night or the Monday morning here, many local commercial stations will close down for maintenance purposes. So that's one of the very good opportunity for us to catch the signals from distance. All right. So this is slide number 3. I hope you can see it now. That this is the picture of the venue or the meeting room that we are using. That is the Tanohata Nature Training Center. I just translated it in English with the meaning. It's not the it's a training center, so it's kind of renting space for such trainings. They are not um, they are not intended for the DXers, but actually some of the college students for doing some kind of sports. They will stay here and meet and do some gatherings. So just a little bit about the introduction of our setup or the equipments that we have been using. As Gary-san mentioned, there are SDR receivers, such as the pair cells for many years. And recently we used Airspy HF plus Discovery. Then using the software of SDR console that you maybe well know, you know of. And as for the playback software, we use the WaveView DX. This is kind of new software developed by Mr. Reinhardt in Germany, and it's a really nice. It has many features and evolving very fast. So we are enjoying using it. So that WebView actually contributed a lot to analyze such data, I think. And also that many of us are radio amateurs, such as me. So many times that we want to transmit at this nice place, for yeah. Actually, 2 years ago, I brought the KX2, the small transceiver with the maximum 10 watts. Then that makes me also easy to communicate, or actually FT8 digital signal to the state side. So it's a very nice place. This is the picture of the venue at the antenna side. So as you will see that one of us is
Can you put
standing.
the headset on?
Can you hear me? Okay. Yeah, one of us is standing, and as you see the sun shades, this is the afternoon that we are preparing for the antenna. So that means that the direction is just like a northeast. The sun is now coming from the other side. So this we put the antenna. This is a very very directional, and also this is not kind of transmit antenna for transmission, but this is mainly, or this is purposely with very low gain, and this is only this kind of antenna is only usable with the very low noise amplifiers. Commercially made, the amplifiers just like FLG 100 from Wellbook in UK has been around, and we also use the homebrew amplifier for the expedition setups. And as you see, the size is about the bottom is 20 meters. 20 meters. 20 meters must be how it's at about 65 feet, I think. And so the total just like 130 feet long length. Maybe next slide will be better. So this is the one. So we use the matching the terminator register and the matching transformer. Yes. This is like a double triangle shape, but that the line is like this. The blue line is continuing, then returning to the other side. Okay. So from here, there's a couple pictures or screenshots from the WebView DX playback software. This is one of the sample for 10 kilohertz spacing on 9 kilohertz. As you do know that in Americas or North America, South America, your medium wave stations channels separation is 10 kilohertz. So left-hand side picture shows the 10 kilohertz radio stations heard. Some of the frequencies are the same with the 9 kilohertz spacing. So it's not all trans-Pacific signals, but mostly these are the signals from North America. Under the November 8th, 9th, the condition was rather stormy. Then we noticed that that transpolar propagation was not possible, except some of the very strong Alaskan stations. So the most of the stations that we heard on these days, were from California mostly, and then there are 2 Oregon stations and about less than 10 Mexican stations. Those are the stations that should be hiding here on this left-hand side screen. Then right-hand screen shows the 9 kilohertz spacing. This is mostly from domestic and also local stations. As you see that the starting time, there's black, then getting white, and getting green. I mean, on top of the bar, it's the time. I mean, it's starting from the 6 or 7 UTC, and the bottom is like 8 UTC here. Okay. So then next slide. This one is the 9 kilohertz imported view of WebView DX on November 9th that we are going to talk about. This is something that made me very surprised, and I've never seen such black portions on the WebView DX when we DX. This is something. It means that the signal has dropped significantly or almost gone out. It just suddenly gone, and it's coming back in about 30 minutes. So it was on November 9th, and from 7:15 UTC until 7:45 roughly. So roughly 30 minutes or so. I have never seen this one. So that's the starting point that I started to contact Nick Holbach, Nick-san, and then we exchanged 1 gigabyte memory to the international couriers, then back and forth, and we just analyzed. Nick-san was very helpful doing it. Okay. The next slide, we tried to think about what was the attenuation. Actually, the local sunset affects such attenuation sometimes, but not so in this kind of level. But that was one of the thoughts that we could think of. These sudden drops in signal strength corresponds quite closely with the sunset, actually. But normally, a time of disturbance, it's the time of the disturbed propagation anyway. But next slide shows that 2 slides. At the left-hand side is the previous day of November 8th, 2025. And the right one is the previous year, 2024, 26 October, that we go to that place almost annually, once in a year, to hear the DX. Then this comparison shows that there were no such sunset propagation dropouts or attenuation. It not that kind of things can be seen here. So this is the comparison. Then back to the chart, back to the this screenshot of the 8th, sorry, 9th November that we are checking. We also noticed that there were very strong earthquake happened on that evening, actually in the middle of our DXing sessions. So actually on that site, many of us had kind of thinking that it it might be something might be recorded on our signals. I mean recordings. That's also our starting point to check what has been this one. What's this attenuations. And also, as you see that the earthquake happened about 30 minutes later or after past 7. Later, the Nixon will explain a little bit more. And the relationship of this earthquake and the medium wave dropouts has not been reported, or we do not have any scientific, or we do not have any reasons to that. It's been reported for the very low frequency VLF signals affected by the just before the earthquake happens in many of the reports, but we've never seen this kind of report on medium waves. So the question will remains what has been the reasons. To further analyze the data, we tried to separate the two groups. One here that here right hand side has the log, the station names and the frequencies and station names and the location, with the colored with the blue. That means that no visible attenuation at that time. And also the left hand side group, this is the red colored. These are the stations that had heavy attenuation on that time. Then I just try to put them on to the map. It's these days it's quite easy that all we have to do is just put the data to the AI. Then that made this kind of map instantly. So the blue portions northeast or north of our venue, and red stations that is the heavily attenuated ones. Those transmitter locations south or west of the venue. So this was one of the keys that we are going to find the reason. On the right-hand side, this might be also popular. This is the DX Atlas screenshot of that that day, the sunrise or sunsets, or the gray line is shown here. It's like that on November. Then also, while we discussed with Nixon, Nixon also mentioned that there are other possibilities, not only the domestic stations, but some of the signals from outside Japan, such as northeastern part of China. This has been also logged and also analyzed. This was a little bit difficult part for me because of the language and also the many stations on the same frequencies. But actually, trying to find out these stations, then plotting them, it was very, very helpful for us to move forward, to have more ideas or the more to analyze the data. Actually, sorry. Then I just once again put them on to this is a Google map with those blue and red stations locations. Okay, I think that until here I will be the one. Then I will pass on to Nixon for further analysis. So I will just stop sharing now. Okay, so I think Nixon, you'll be the one from here.
Okay. Yep. Just yeah, a brief break. Maybe somebody could do a commercial or something like that. Um, but all I have to do is find my copy of. There we go. Okay. So are you now seeing my screen, which should be the next slide of our presentation?
Yeah, if you could zoom in a little more, I think that'd be helpful. It's about 50% scale right now.
Gee. Not sure how I can do that. Sorry.
It's looking
Go to
great here.
presentation mode.
Sorry.
Can you go to presentation mode? Just press
Okay.
like F5 and go to presentation mode.
Okay. F5. Actually, all I'm bringing up on this screen for some reason is just the zoom. Let's go back here. Okay. F5. There. Is that better? Except now, of course, I'm at the beginning.
Yes.
Yeah. Okay. Got it. Excellent. Not used to this stuff. Okay. So let's go back. Okay. So here we have the comparison of the earthquake intensities with the attenuated signals. And we have to keep in mind that actually this was a precursor observed, but the easy information to get is the intensities of the earthquake itself, which is what you see on the left-hand side of the screen here. And so we'll just try a brief look at the comparison of the attenuation versus the intensities of the earthquake. And up in Hokkaido, the northern island of Japan, which is where there was no attenuation recorded, the earthquake wasn't felt as heavily as it was in the sort of northern portion of Honshu. But you know, there was still some intensity felt. You look down at the southern portion of Japan, we actually had a number of signals coming from the southern portion of Japan that were attenuated, but there was no earthquake intensity, you know, really at all. And so we're sort of wondering, well, you know, obviously, if it's a precursor, maybe you know the geological changes would be different from the actual sudden shock of the earthquake. But you know, to be honest, we were sort of stuck. We were sort of saying, well, we don't have easy information to geological changes beforehand and so forth, and so we were pretty much stuck at saying, okay, well, maybe we'll just present the information and maybe somebody else will be able to give us some pointers as to where we should go next. But before we sort of threw up our hands, we sort of, well, maybe is there some other possible cause of these signal dropouts we mixed? So we looked a little more closely at the signal strengths, and you know, although the attenuations definitely occurred to the southern portion and up in China, what was really interesting was that the signals that were further away and further into that they were the ones that actually had some really definite attenuations, and the ones that actually caught our attention in the first place. So we updated the Google map, and you can certainly see from the, you know, what we're using is the yellow pins as indications of what the strongest attenuations were. And you can definitely see there's, again, a very definite geographic, you know, sort of listing of these, you know, compared with the lesser attenuation or no attenuation. So we'll look a little bit more at an example. Here, what we'll do is we'll look at a signal from Niigata on the west coast of Japan, which is not too far. It's about 300 kilometers from Tonohata. And we'll also look at a signal from Hiroshima, which is over 1,000 kilometers from Tonohata, and just compare what they look like in terms of attenuation. So we've got a couple of signal strength displays here, and it's quite obvious that the one from Hiroshima, you know, that's further away, has a very sharp and very definite attenuation, whereas the one from Niigata, which is closer, is, you know, definitely there's attenuation, but it's not something that sort of leaps up and sort of grabs you by the throat. So let's look again at this sunset terminator, which Miyao-san was mentioning a little earlier on. It's probably a little more important than anything to do with the earthquake. And sure enough, if we look at the unaffected signals, they're in the nighttime side of the terminator, which is that white line that we've drawn right through Tanohata at 0722 UTC. You can see that the nighttime side, yeah, no real attenuation occurring. But on the daytime side, signals that are coming from the daytime side, they're definitely attenuated, and the further away and further into sunlight they are, the more deeply they're attenuated. So is this a hint? Well, what would affect propagation signals at medium frequencies only on the daytime side of the terminator, but not the nighttime side? And why would more distant signals on the daytime side be attenuated more? And when you come to think of it, well, what about a solar flare? That affects signals on, like where the sun is visible, in other words, on the daytime side, but not on the nighttime side of the Earth. And in fact, when we looked it up, there had been an X1.7 solar flare that had peaked at 0735 on 9 November. It had been reported by Japan's National Institute of Information and Communication, as well as by NOAA. And here's something from NCIT, the display, and sure enough, 0735. They're showing Japan time. We've just changed it to UTC, which is more common for the rest of us. And they actually wrote a report on that solar flare and said that observation by the ionosonde in Okinawa, which is far to the south of Japan and very much in daylight, it actually said, well, like the reflections at the reflections at the low frequencies of the E layer disappeared between 0710 UTC and 0735 UTC. They described it as a Dellinger phenomenon, but we know that better in America as a radio blackout. So does that provide us with an explanation for the signal dropouts? We think it does. The first order simulation of medium wave skywave propagation is that it doesn't happen in the daytime because the signals are too heavily absorbed due to the solar illumination of the D region. But in reality, the hours around sunset and sunrise, like on the daytime side, feature a much less dense D region because the sun at that point is, at quite a steep angle. And it's not actually causing ionization of the D region nearly so much, and particularly around the winter solstice in temperate regions. This allows medium wave signals to actually propagate by skywave from the daytime. And this is, you often hear about 160 meter DX'ers saying that like that so-and-so peaked just after sunrise at my location. It's propagating into the sunlight area, but the D region hasn't built up. So in this case, it looks as if the X-rays from that major solar flare induced an attenuation that was at least as equivalent to what the attenuation would be in the D region in midday, and maybe even more so. And we thought, okay, well, let's take a quick look at the progress of the X-ray flux from the solar flare and compare it with one of our signal strength traces. And sure enough, the blue here is the progression of the X-ray flux from the solar flare, and it's compared with the attenuation from the signal from Hiroshima that we were observing earlier, and it correlates pretty nicely. As the solar flare builds in intensity, the signal just drops off, like at 30 dB in 5 minutes. So in conclusion, over less than an hour, we had a number of temporarily attenuated signals observed at Tanohata on 9 November 2025. And during the hour that this took place, two completely unrelated events, major events took place. One was a nearby earthquake, which was definitely noticed by the attendees at this DXpedition, and the other was a solar flare. The earthquake caused us to actually look a little more carefully at these attenuations because, well, like what caused the attenuation? There was an earthquake. But it wasn't until we actually looked a little more carefully that we started looking a little, really looking a little more carefully and discovered that, well, it was a solar flare. And really that explained it much better than anything to do with an earthquake. So there you go. Thank you from both of us. We had quite a time preparing this. And if you want more information, there's an appendix here which gives a couple of links to Miya-san's organization in Japan and some recordings of what they heard while they were at this DXpedition. So thank you again. And,
Thank you.
okay. And now we can see, can we get out here? And I never know what's going on with this. When I'm sharing screen, can you kill my sharing from there?
I might be able to. Let me take a look here.
Yeah, because I've seemed to have lost my controls for this. Okay.
There you go, buddy. No problem.
Right, thank you. Okay. All right, stand by for any questions to Miya-san and myself.
Very nice presentation. It was very easy to follow the progress of your logic. So that's very helpful.
Yeah, it took a little longer than the presentation did, though, I can assure you, the actual progression of the logic.
From the signal dropout that you had recorded and put the graph, it's really similar to what we see on HF when there's an X-ray flare. If I take Gary's graph that I did last week, it's very similar. I can prove.
Yeah, in fact, like this is why we didn't immediately pay attention to the solar flare, because the early term for this was actually by the gentleman Dellinger, who was the Dellinger phenomenon. He actually, I think, coined the phrase shortwave fade out, because what it was doing was killing the shortwave links at that time were quite important, like say across the Atlantic and things like that. Like there was traffic going across, like commercial traffic, and all of a sudden they'd lose all the signals. And this was from the solar flare. And that's so yes, what you're observing is it's just that shortwave was so reliable, and over such long distances that it was shocking to actually have the signals drop out. But in this case, we didn't expect to see it because, like medium wave signals really only travel at night. But in fact, in this particular case, the effect of the solar flare could be seen because we were receiving signals from the daytime side. But like a lot of the shortwave, particularly above 10 megahertz, is actually propagated best in daytime, and so the shortwave fade out hits them very, very hard indeed. In fact, the other flares that were noted by the Japanese organization are, they were all in the daytime, so we would not have noticed them in any medium wave propagation because there wouldn't have been any medium wave propagation at that time. Anyway, back to you.
Thank you.
I think it is interesting to see also the way Miya-san and his group will take basically DXpeditions to do listening and recordings like this. I mean, so many of us are used to doing that for transmitting and for two-way, but to do it for receiving as well is interesting to see.
Yeah, the beauty of the receiving part is that with the modern sort of SDR programs and the playback software in particular, excuse me, you can get like you can derive signal strengths and so forth. You can get the displays of like what's happening with propagation not so much, well, some of it you can do pretty much in real time, but certainly after the fact, you can get a really clear idea of what has happened over a certain period of time.
And I think it gives a new definition to the meaning of field work. Gwyn, you had a question?
Yes. Well, first, thank you so much, both of you, for a lovely and informative presentation. A question, Nick, you just mentioned the replay software there, and you were at a DXpedition site, which might be low local noise, perhaps. Were there any unoccupied channels in your bandwidth, such that you might have been able to see if the propagated in noise on unoccupied channels was reduced as well?
I'm gonna hand this back to Mia-san because he was there and I wasn't. But he actually observed sort of thunderstorm static and the changes that occurred during this event. So maybe he can clarify that a bit more.
Yes, actually, it can be heard. Actually, there were, I think there is no vacant channels, but there are places that not many many stations are heard. So tentatively, I think we use that 530 kilohertz or the just a band outside of the band. It's also recorded with the 2 megahertz space has been captured in the PC. And then that the you know that the talking about the noise, yeah, as Nick mentioned, that we actually felt much noisier and also gets noisier into the time of the earthquake. We don't know yet, but there might be something to do with that, or there's a mixed reasons maybe behind. There were some actually the thunders happenings off the coast of the Pacific and also the other side of the ocean. So maybe that might be the case. But that definitely what we can say is that November 9th is especially at the near to the earthquake time got to be much noisier than previous day.
Thank you.
And I will interject though in that when Mio-san mentioned that they, you know, this whole monitoring of a static noise, it turns out that with the software we can actually, you know, sort of record the signal strengths over, you know, very sort of fractions of a hertz bandwidth. And so we chose a number of, and didn't get into the presentation, we chose a number of frequencies throughout the medium wave band and actually recorded the noise level that was on those, you know, on those very sort of limited bandwidth channels, and then averaged them all together. And they're not so sure about, you know, like whether because the earthquake occurred actually about half an hour after the attenuation event. And so I'm sort of wondering whether what we were actually observing was that the noise level dropped at the same time as the you know, the broadcast signals were dropping. They were attenuated because they may well have been from thunderstorms to the south of the site in you know, like in late afternoon. And then as the earthquake time approached, the solar flare was dropping away. And at that point, the noise level started to come back up along with the broadcast signals. So that's one of the reasons we didn't put it in the presentation, because it's a bit of a can of worms. Not exactly sure what was going on there.
Wonderful. Any further questions? Well, thank you again, Nick-san, Mia-san, for a very nice presentation, and of course for getting up so early to deliver to us during our normal time slot here. We spend so much time looking at HF, and as Nick will tell you that sometimes the medium wave gets a little bit of a short shrift, but it was good to see that focus today.
Yeah, thank you very much for your time, and also that actually on this D expedition we could hear about 70 U.S. mainland and mostly the California stations and Mexican stations. Sometimes or one time we could hear the distance-wise that we could hear the South America, Uruguay, Argentina, those stations. And also one time it was very exciting to have the WBZ from Boston. That's
Wow.
the transporter. That's very difficult. So it's nice location for DXing with the very quiet environment, noise wise, and it's nice. So that we welcome you to come over here. Maybe also for transmitting. It's wonderful.
A question I just thought of, I was thinking of how many years you've been visiting this site, because of course on HF we make a big deal about the solar cycle and the change in the solar activity. Do you see the same thing on the medium wave bands, or is it a change in noise, or is it a change in signal strength across the cycle?
Yes, it's been less than 10 years actually, but the WBZ was heard on 2020, I think it was. So that it's almost the sunspot minimum. So I do not have see any of the environmental or the reception changes actually so much, but it really depends. It's just only a couple of days, only 2 nights, so it more depends on the conditions of that day. If we are lucky, we can hear. But if we are not so much lucky, that we may not be able to hear so much stations, just like we did on the 9th November. 9th November, the propagation wise, medium wave propagation was good, very good, especially compared to the previous day. So that it was very nice day for us to record. To playback with the DX WebView DX. So I have been concentrating on the logging or identifying the stations from North America with 10 kilohertz. But suddenly that I just noticed that there were some strange blackouts or the attenuation noted on the 9 kilohertz. So that was the starting point of this project with Nixon.
Excellent. Very nice. Very nice. All right. Thank you again. Is there open it up to the floor? Any other comments or questions for the HamSCIence group today?
I was just going to interject. Thank you so much for introducing me to this new piece of software. I'll definitely have to check it out.
And I also like your website, which I just went to. That's a very, very nice website.
Oh, that's the TDXC is the Totsuka is the name of the place, and DX circle that we actually that put up the magazine or the propagation software. I mean one of the articles mostly written in Japanese language, but I think that it's kind of interesting to the radio amateurs as well. Most of the articles are all for medium wave or kind of short wave or some memories from before, those kind of things. But thank you.
All right, very good. I see Nathaniel popped in earlier on. Nathaniel, you have any? If you got a minute, do you have any comments for the group or comments about how things are going in general with HamSCI?
I think things, yeah, thank you very much. First, I just want to thank our speakers so much for this really great presentation. I think it was just excellent. I thought it was a very nice presentation of these observations. And it's really nice to meet you, Satoshi. And Nick, also thank you for working on this. And I think this is exactly the sort of thing that I really want, to see HamSCI do. Like we're really seeing these really nice presentations that are being led by community members, and I think getting to this level is exactly what I would hope HamSCI to be. So I think that from listening to the discussion, it sounds like this sort of there's quite a bit of interest in this sort of thing, and it's this sort of presentation is helping to give other people ideas and give you good feedback. So I'm just super, super happy with this. Next, I think HamSCI is generally going very well. The big thing that we're working on right now is getting ready for the HamSCI workshop, which is going to be March 14th and 15th up at Central Connecticut State University and at ARRL headquarters. So abstracts are due tomorrow. Well, I guess no, they're due February 1st. So January has 31 days, right? So we have a couple more days before February 1st. So they're due on February 1st. So please get those in. Nick Hall-Patch, Mio-san, I think this would be a great abstract to put in. I see some questions about hotels. So I'm still waiting to hear back from the ARRL on the hotel situation. And so I don't know the hotel situation yet. I think they do have some local ones that they are trying to get some rates with. I have a meeting with the ARRL on Monday morning to get caught up on all of the local organization planning. So I will make sure, and I did send them an email last week asking about hotels. So I know a number of people are asking for that. Hopefully we'll have that up this week. We are also going to HamCation, Orlando HamCation. So we have a booth down there, and I'll be giving a talk, and Gary will be giving a talk, and Bill Engelke will be giving a talk, and my wife will be giving a talk, and there's going to be a booth, and Ed's going to be there too. So anyone who's at Orlando HamCation, we look forward to seeing you there, and please feel free to come by and hang out at our booth. I'm also getting a big award there at the dinner, so that's kind of cool. We've got we just saw that our new research assistant here, Emma, she just had an article published in APJ. That was the result of her work when she was an undergrad. So she did not do the work here with HamSCI, but it's a really nice article, and it's really nice to see that we were able to have someone as qualified as her come and join us and work with us. I also know it hasn't really been announced yet, but the Case Western group, they had an article accepted into Frontiers about the eclipse. And Steve Serwin and my team, we had an article accepted into Frontiers about the eclipse as well. And as soon as those are actually available on the websites, then we'll make announcements about them. I think that's a lot of information. Anything else, Gary?
No, there's obviously a lot of things going on, a lot of moving parts, so that's fantastic.
Yeah.
We had a very busy PSWS call this morning. Since the first time we got together since early December, those of you who were on it, it sounded like there were a lot of cats and not so many people hurting them, but that's okay. We'll get things done. So.
Yeah, sorry I missed that this morning. So one of the things we're doing, University of Scranton is not traditionally a large research university, so it's challenging managing all of the grants over here. So we're doing things. I was in a meeting this morning about how we manage that better, and so I think we are getting off to a good track on how to do that. But that's where my attention was this morning. So I'm glad. I imagine Christina was on the call this morning.
Yes.
Yeah, that's good. I'm sure that she was doing a good job kind of organizing things there. So, yeah.
You never know from the news, but there was something I saw in the news a few days ago. Apparently, the United States Congress is starting to get the picture and understand that funding science is pretty darned important. I think their constituents at universities and other places are probably let them know that the loss of funding or potential loss of funding due to some of the political issues was not welcome. So maybe some of that tide is turning in a positive direction. So we can hope.
I hope so. And, you know, we actually have a NASA grant that Kukai is the lead PI on. And that grant was actually selected back in last fall. And we haven't made any announcements yet because even though it's been selected, it hasn't been formally awarded yet. And I think, you know, they might be dragging their feet. So now that, you know, maybe this, you know, round of funding got passed through, maybe we'll actually see that officially get awarded. So yeah, this might be directly affecting us.
Yes, challenging times, no question about it. So,
but I think this is all really good. I'm glad to see so many people on here and everything. So yeah, that's all from Scranton.
Great, thanks for the update.
You're welcome.
All right. If you guys, we got a couple of minutes. I was doing some traveling a week ago, and I got a couple of pictures I'd like to share just because of the subjects of the pictures. I think they're pretty interesting. So let me do a screen share here. So I happened to be in London, and was walking. My wife and I did a lot of walking everywhere we went, and we walked past King's College there in London. And on their walls, they have these photos of either famous graduates or staff members. And I picked up on a few of them. Of course, Wheatstone. Every electrical engineer knows what a Wheatstone bridge is, but his name will come up again in a second. Let's see. Come on, let's change. Yep, James Clerk Maxwell, right? Where would we be with radio and electronics and magnetism and all that without Maxwell and Maxwell's equations? He was a professor of natural philosophy at King's College, so I was impressed by that. But this one I thought was the most interesting, Appleton. At first, the name didn't register with me, but then I started to read the panel. Let me zoom in a second. He was awarded the Nobel Prize for Physics in 1947 for his investigation of the physics of the upper atmosphere, especially for the discovery while he was the Wheatstone professor at King's College of the Appleton layer, which I think was the F or the F2 layer. He got the Nobel Prize for. So it's not often that you're walking down the street and you see a photograph of somebody who was involved with atmospheric research. So I had a lot of fun with that. That's why I had to snap
That's really
a photo.
neat. And you know, we also hear Appleton's name all the time. We talk about the Farlap ray tracer. All those ray tracing equations that make Farlap work, they're known as the Appleton-Hartree relations. So you can go look those up, and yeah, those are all his equations.
And this year is the 100th anniversary of his discovery with his assistant of the Appleton layer, the F region.
Very timely then.
Very timely. Lovely photos.
There's a couple of more. I happen to be in, take a tour of Westminster Abbey. Let's see if it'll, oh, come on, let's advance. Oh, here we go. And Westminster Abbey, of course, there's a lot of people buried and a lot of memorials throughout many of the historic buildings in London, and actually all of the UK. And there was James Clerk Maxwell's final resting place. Michael Faraday, his final resting place. There's Lord Kelvin. And this one I thought, Mary Lou, you'd particularly appreciate. Edmund Halley had a large memorial there for his first to predict the return of the comet that was named after him. Good old Edmund Halley. Let's see, there was a couple others. Stephen Hawking was the last person. His remains are entombed in Westminster Abbey. He was the last person to be entombed in 2018. And the story went, I was listening to a tour guide, that he didn't feel that he was should be interred there. He didn't think he deserved the honor, but apparently near the end of his life he changed his mind. And that's where he's at, Stephen Hawking. Isaac Newton, right, talking about physics, and this seemed like kind of a small memorial for Isaac Newton, you know, just another black stone on the floor. But then I dug a little further and looked around a little bit, and that is Isaac Newton's full memorial. It's a little more intricate than just the black stone on the floor. But there is Newton, and apparently this globe, this woman on top of the globe represents astronomy. But to see Isaac Newton and his actual final resting place, and of course I don't read Latin, so that went all over my head. But anyhow, just some of the giants in the world that we work with and depend on, so many people that came before us. Kind of interesting.
That was really cool. Thank you very much.
Sure. All right, we're just about at the 5 o'clock hour, so I guess we call it a quits for a week. Sounds good? All right, everyone. Have a wonderful week. We'll see you hopefully on another Zoom session soon, maybe on the air or crossing paths via email. So 73, I'll have a good night.
73.
Thank you.
7-3.
7-3.